All right, so our training, as you might have already figured, it's all about DevOps and containerization. That's what we primarily focus on. So we will be talking about the best software practices and software delivery practices that the industry follows today, and a lot of automation, how we can automate them, right? That's what DevOps is all about. We will uh, we will talk about that. So initially, there would be main four courses that we are going to cover in our training. Major four courses would be there. I will talk about them. And before we start with any of these courses, there is a 2 weeks of prerequisites training that you need to complete. So if you consider prerequisites as one course, it's going to be total 5 courses that we need to complete in this training. And every course will take 2 weeks each. And the prerequisites training, it's all about getting you started. You need to get an understanding about what is software and what is a web application. How do you run a web application in a Linux environment? How do you serve a website to people, right? You can run a web application in a Linux environment and make this application available to the people. They can browse using their browser for your website and they can see your website, right? We will see how web application works and what are the different components of a web application and how does you containerize them, right? Containerization just means that rather than setting up the application inside a machine yourself, you would use containers in order to run your application. We will come to that, right? So it is nothing but some Docker, understanding what is Docker and how exactly you can package your software applications into Docker containers and how this Docker containers will work together and serve your customers or serve your related teams. So you need to get a basic understanding about all these things in the first 2 weeks. That's what the prerequisites training it's all about. And once we are done with the prerequisites training, we will have four main courses. One course is all about the configuration management and the practices. These are the main courses, right? Just yeah, take a look. The first one would be continuous integration and continuous delivery. It's not 12 hours. All courses are 15 hours each. So this is all about what are the best practices inside a company for software delivery. How do you automate different process which involve different teams collaborations, right? That's what this training is all about. I will talk about that in detail in some time. Then we have Kubernetes advanced training, which is all about running your Docker containers after you develop your software. You will package your softwares into small Docker containers and how you will run these softwares in production. That's what this training is all about. These are the different tools we are learning: Kubernetes and Helm. It's a 2 weeks training. It's a 15 hours training. This is also a 15 hours training, and the tools are Git, then Docker for developers, Jenkins, and Maven. Then we have two more courses. One is container orchestration in the cloud. This is all about how do you run your applications after you containerize them, after you dockerize them, how you will run them in the cloud. That's what this course is all about. It's a 15 hours course. And then we have okay, I think, sorry, we are going to learn Google Cloud, Azure Cloud, and AWS Cloud during this training. And actually I opened a wrong topic list, sorry for that. The next topic would be configuration management, where we will learn how do you manage configurations of your complex software? And sorry for opening the wrong topic list. Okay, so the next one is configuration management and monitoring. This training is all about Ansible and Nagios. So we will talk about how exactly do you manage configurations of a software. Again, I will talk about that in a bit. So before we begin, first I just want to give you a brief introduction about what is meant by software and what is meant by containers. So let us get started. You probably already know what is meant by a software, right? All your company they will have one software. It can be a web application. What is meant by web application? Google.com is a web application, or Flipkart.com or Amazon.com. These are web applications. You can browse a web application on a particular URL. Then your browser will establish a connection to the server, and it is this server which will process all your requests coming from the browser. When you click on, right, for example, you open Amazon.com website, then you got a page from the server. Then you try to log in. You enter your mail ID and password in the given boxes. Then you click on the login button, and when you click on the login button, another request would be sent to the server, and the server will check your email ID and password, validate it, and then the user get logged in. And then you try to create a shopping cart. You just add certain items. You click on some button to create a number of items to the shopping cart. Then what actually happens is another request would be sent to the server. So remember, all the processing would happen over here on the server side. Your browser is just a client being served by the server, right? Create shopping cart is a program which is executed on the server, or adding a new item to the shopping cart is another program which is executed on the server, or deleting a shopping cart, making a payment, right? Any action that you do on your browser, remember, it is the server that will do all kind of processing and finally give you a response. So we are going to talk about such a company who own a particular software application. It can be a web application, and people all over the world using their browser they can connect to this application. Think about a retailer like Amazon.com. So they may have different software applications, right? They will have the shopping cart could be one application. Prime customer would be different application deployed into different machines, right? Then the Paytm payment application, Google Pay payment applications, like that, there can be different applications you can find. Every company will have multiple software components, and because they are developed independently and they communicate each other when required. For example, there can be a front-end component, and what this component does is it will request the web page to the people who requested it. So from the browser, anyone browse for the website, maybe the browser first connect to this particular software component and assume the software is running on a machine, and this machine will respond with a web page, right? Then you will see the web page displayed on the browser. Then you click on the login button, you enter your mail ID and password, then you click on the login button. Then on this side what happens is probably it will connect to a backend, and the backend will check the login credentials that the user have entered, the email ID and password, check if the email ID and password is correct or not. If it is correct, then the user get logged in. Then here try to create a shopping cart. Then there can be a shopping cart component which will get the call, right? It will get the call and it will then create the shopping cart. Then the customer try to make payment. Then a request would be made to the payment component. What I'm trying to say is, in a company there can be different software components running on different machines, and they communicate each other based on the requirement. A shopping cart need to be created, then this software component should be communicated. Or it is a prime customer, then this software component would be communicated to find out what are the offers of the given customer and etc, right? So this is how it works in a company. This is how a web application or a software work. There would be lots of software components which are developed individually by different developers. Maybe there are a number of people working on developing the shopping carts, a number of people developing the front end, a number of people developing the back end, right? And they do the coding. That's what they do, right? Development team, they will do the coding. It can be in different programming languages. This can be written in Java programming language, this can be written in JavaScript, and this can be written in Python, right? It can be different programming languages in which your code is developed in, right? At the end, software is nothing but set of code, right? A number of code, probably a good amount of code wrote by your development team. I mean, don't worry too much about the technical terms which I am using. Just try to get an overview about the complexities or the responsibility as a company when you have to manage a software. So these many things need to be managed by the company, right?
So,
Not easy.
sorry to interrupt. Like, we need to learn any coding language.
No. This training is not about code, and even a DevOps profile is not exactly a coding profile. It is different. You will be
Like
doing lot of
Python, Git.
and you might be doing some scripting too, but not complex ones. So yeah,
Okay.
and
But here in source code is different in Java or other .NET,
you need to
other
understand the
languages
structure.
written, right?
It can be any language. Whatever language or application is developed in, you have this responsibility of building it, then shipping it, running, deploying it, and then run automated test, validate the software. So you have a set of responsibility. Software is not only about coding, right? That is the old approach. Coding need to be done to develop a software, and after you develop this software, managing the software is more complex than developing it. And that is the reason DevOps has evolved as a solution to many of these problems. Like people want to manage a lot of software in their companies. In order to run the software, they need a machine. Before they run each and every software inside a machine, they want to make sure that the machine has all dependencies met, right? To run the software, first you should have Java installed. For example, the shopping cart software, it is written in Java programming language. Now you want to test how the software is doing. First of all, you want to run the software inside a machine. In order to install the software in a machine, the machine must have Java installed in it. Then only you can run a Java based software into that machine. So that is done. But still, that is not the only thing. Every software will have different configurations. For example, shopping cart need to know whom it can call to understand the offers of prime customers. There is a separate software application called Prime Customer. Shopping cart will talk to this Prime Customer application to understand what are the offers of the Prime Customer. So there should be such kind of configurations. you should add into the shopping cart application. And also, when your development team develop a software, when they write the code will depend on some other module, some external programs, external dependencies. So in order to run your program, you should get that external programs ready. That needs to be done. So to manage a single software service, it is a complex process. And think about such a company. And later on, this single software component may be used by your customers a lot. One machine may not be sufficient to manage all your customers, so that you need more machines running the same software component, running the same shopping cart component, serving all your customers. And then there are different teams. You have testing team, you have development team, you have operations team. Then the development team, after they develop the software, they need to get a feedback from the testing team to know how the software is looking, right? The development team, after they finish the testing, the code can may not be cool, right? You need somebody to test the software and make sure that everything is looking good. And then the developers need the feedback from the testing team. So there should not be any manual process at the time of collaboration with other teams. All these things should be automated. The test should be automated, or the deployment, the delivery, all the process should be automated if you want to manage things in a proper way. And that's what DevOps is all about. After your software is developed and it's ready, and right, you cannot say your software is never ready, right? For a company, software development is a never ending process. They keep on adding more and more features. They will keep on adding more code. They make modification to the code. It happens continuously, and the testing should happen continuously. Delivery should happen continuously. Deployments, running the software in machines, should happen continuously. So there should be a proper team who administer this whole automation process, and that's what a DevOps team is, right? Other than coding, you can say almost everything. All right, yeah. So what we discussed so far is about a company, a retailer company, who want to run their software application. So they face all these complexities. Like I said, if you have a program, assume you have a simple Python program with you. And whenever you write a program, whenever a developer write a program, he will use some functions which is available on some external programs. In short, you can say that your program might depend on some other programs. And you want to run this program inside a machine. Assume there's a machine, and inside this machine, you want to run this particular program. So first of all, you must have Python installed in this machine. Then only you can run a Python program. That is one thing. Then you want the program to be copied in this machine, and you want all these external programs to be downloaded to this machine. And now the program is ready to run inside this machine. Right? So it's simple logic. So then only the program can be run. And a real software application is not a single program. It can contain multiple programs. Think about the shopping cart application. So one program for shopping cart creation or adding items to the shopping cart. Another program for shopping cart deletion and removing items from the shopping cart. Another program to do the calculations, calculating the price, calculating the total price, finding the discount, applying the discount, right? All so there can be a number of programs for a single application wrote by your development team, and all this program depends on different dependencies, and all these dependencies might depend on other dependencies too. Right? These are called transitive dependencies. So to run such a complex application inside a machine, it's a lot more. And also you want to write the configurations, right? I told you shopping cart component want to know how it can talk to the prime customer component. So you want to tell this is the IP address of the prime customer component that you can connect to and you can talk to. So there can be a number of configuration that you want to add into the shopping cart software. So in order to run such a complex application, you need more things. You need, assume it is developed in Python, you should have Python installed. You must have all the program present in this machine. You should figure out what are the dependencies and what are the transitive dependencies. Download everything inside this machine and finally make it ready to run. Make sure that all configurations are present and then only your software becomes ready to run. So instead of following this approach, there is a better way today, right? Actually, it was not there. Not all the companies have adapted it yet, but every company will soon, they are going to do that. It's called containerization. And Docker is one tool which can do this kind of containerization. So what you actually do is, rather than your development team developing the code, then your operations team right, spend their time to create the machines, copying the code over there, downloading all dependencies, and making the machine ready to run the software. And then your testing team, what they do is they will just do some testing on this machine, make sure that the software is running fine on this machine, doing everything as it is expected, right? Rather than doing all these things, your company would start developing a Docker image. And inside this Docker image, it contains your shopping cart software. That means all the program developed by your development team and all the dependency the program depends on, and Python installed, all configurations, whatever configuration you are in short, you can say whatever other things shopping cart need, you put them all together inside a single file. And assume your company start to develop this file rather than focusing on developing only the code, then things would actually become very easy for everyone, right? Anyone who want to run the software, they can just run it anywhere and whenever they want, because they don't need to worry about downloading the dependencies. They don't need to worry about setting up the environment where the program can run. They don't need to worry about adding the configurations. It happens automatically because it's all there in the file itself. This is what your company is developing rather than simply developing the code. Now it's ready to run anywhere. Anywhere you want to run it, you can just create a Docker container from this file, and that's it. Your shopping cart would start running. You don't need to put anything else in here because everything is already there. So this is a new approach how companies want to follow, or what companies actually want to do, right? So it would avoid a lot of headache for different teams. After your software have been developed, you want to test your software in many machines, not only, believe me, there are different environment. A company want to run the testing, and there is a dedicated testing team who want to run the testing. So they want to first run some testing on within their laptop. Then they want to run the testing on an environment where all software components are running. Then into different environment, and finally the production environment. This is the environment that would serve your customers. When I browse for your website or Amazon.com, for example, my browser connect to the machines. In this environment, there can be other environment which is used only by your internal team, only for testing purpose. Because before you copy your latest code in here, First, you should test it properly in a internal environment that your company have, right? And again, don't worry too much about the technical terms that I am using. Just try to follow the concept. So if you have a Docker image, you don't need to worry about deploying 100 times, right? There are different environment, and daily you want to deploy multiple times the same environment. If you have a Docker image, all you have to do is just run the Docker image, create a container, and your software application start to run. There is nothing to worry about the dependencies or anything like that. So this is the intention, and in such a company, in such an environment, what are the best practices or how we are going to do the development? I mean, of course, not the coding. You are not going to learn the coding in this training. This training is not development course. It's purely DevOps. But you will be learning some scripting, because at some point of time you have to use some scripting, because the tools might not support everything, right? You may have to write your own script, but very small ones, and whatever you need we are actually covering. We have shell scripting and Python as a self-paced training. Then apart from that, some other small script need to be done. It's not a big deal, believe me. It's not a big deal. But we don't do any kind of advanced coding. It would be just small automations that you want to do. That we will be doing. So again, just take a quick look at the topic list. Yeah. So again, take a quick look on the topic list. So we have a prerequisites training, and these are different tools and technologies we are going to learn. We will learn how to set up a sample website. First couple of days we will focus on Linux, because you need an understanding about Linux and the basic commands of Linux. That we will begin in the first couple of days. Then we will talk about some web frameworks, what is a web application, and we will run a website on a Linux environment. And then we will talk about how do you containerize your application, how do you create a Docker image of that application and run the software like a Docker container. This is very important. Actually, the entire prerequisites is very important. And then how they communicate and how you orchestrate it and run it in a real environment, right? All these things we will discuss. Just, I mean, the prerequisite is all about an overview and getting started, because you must need certain things completed before we begin with the actual training. Okay, after we are done with the prerequisites training, we will move on to our main courses. On all main courses take 15 hours, not 12 hours. Sorry for marking it wrongly. And our class timing will also change. As I told you, first 2 weeks, the class timing will be 6:30, the same time as we started. And after 2 weeks, class timing will change to 7:30. First 2 weeks, it would be 1 hour per day. After 2 weeks, it's going to be 1.5 hours per day. The classes are Monday to Friday, India time. In US, it's going to be Sunday to Thursday. Okay, just make a note. This is how our timing will look like, and the duration will be 2.5 months or 10 weeks, because 5 courses, 2 weeks each, including prerequisites. So the total duration will be 10 weeks for this course. And during the continuous integration and continuous delivery, we will talk about how the development team do the development of code, And how do you automatically download all the dependencies of the code? How do you run some basic testing automatically? How do you create a Docker image? And then after creating Docker image, how do you validate the Docker image? Then once it is validated, you will upload the Docker image into some registry. And how do you run this Docker image inside a machine? Right? How do you automate this whole process? That's what the CI/CD training is all about. Very, very important training. It would give you a lot of insight to a real-time working environment. We talk about different teams working in a company and how DevOps engineer collaborate with them and what are their responsibility. How do you help them automate certain things, right? All these things we will be discussing. And then we have Kubernetes advanced training. This is all about serving your software to your customers, right? Serving your software to your customers. That's what this training is all about. After you dockerized every software, how do you run it in a production environment, or how do you make it live to your customers? That's what this training is all about. These are the tools: Kubernetes, Docker. Over here it's Git, GitHub, Docker, Jenkins, and Maven, etc. Then we will talk about the same Kubernetes in the cloud. How does it orchestration work in the cloud? If you are using most of the company today, they are using a cloud environment in order to serve the customers. So we will talk about how exactly it will work with the cloud. Different cloud we are covering: Google Cloud, Azure Cloud, and AWS Cloud. Then we have configuration management. This is all about, I told you, every software will have different configurations. How do you manage it? And also some kind of monitoring that we will be discussing during this training. So these are the four main courses we are going to cover. And we also have shell scripting and Python, but that we are not, it is a toddler ways of classes. But it is not a class, it's not a live online program, it's going to be a self-paced video course. So I would give you access to the portal and the videos. You can just complete it yourself. It would be available to you, right, as a free course. You can complete it at your convenience. So these are the programs included in the training, and that's the plan. That's our plan for next 10 weeks, right? And you will get access to a portal. You all need to register. You can do it now. Go to basil.edudoor.org and register yourself. You can do that now. And those who are new to IT, please don't worry. I mean, it's not, you can get started during the prerequisites, and once you are done with the prerequisites, it's pretty much straightforward, right? There would be some extra effort that you need to take to learn some Linux basics and making yourself comfortable with Linux, right? These are things you have to focus more, and there would be lots of practical. You should do almost everything what I do in the training, and also the assignments, and make sure that you are completing everything. And yeah, what I want you to do is go ahead and register on this website. I just pasted you a link in the chat. The website is basil.edudoor.org, and you will see an option to create a new account. Just click on this button, create a new account. Provide your name, username, email ID, and password, and then click on register button. So once you register, then I need the approval from your billing contact person, right? Whoever contacted you, talk to them and request for the access, and you will get access. So just once you got the access, you would be able to see all the courses, right? So once you got access, you would be able to see all the courses listed down in here: continuous integration and continuous delivery, shell scripting, or whatever it is, container orchestration. Okay, this is also one course you are going to get access to. It will be free. It will be a self-paced video training. Amazon Web Services we are going to cover in detail. Not in the class, but it's a free class. you would get access to. It's a detailed training on AWS. All right. Yeah, this is how your courses will look like. There would be different link, different assignment, and everything. Right. So you have to complete reading all the links, assignment, etc. And for those who are new, there would be more reading and assignment that you have to complete. So I will just, you would get access to all the courses. You can open it, you can see all the data, different pages that you can read and understand. These are some extra. You will get access to this for 3 months, and also the videos. Everyday class I will be recording, and the videos would be shared with you. You would get access to that. All right, and if you want for more than 3 months, that is also possible. It is extendable at a small price. Actually, some 250 rupees or something per month. Not sure, but yeah, and that it's going to be cheap. All right, yeah. So that's pretty much I wanted to discuss today. We will start day after tomorrow, same time, same link. We will start day after tomorrow. We will talk about creating your lab environment. First of all, you need an account in the cloud and you need a Linux machine. So we will talk about that. How do you set up your lab environment? And we will talk about that day after tomorrow, first class. And then we will start with the Linux basics next day. That's our plan for this week. Any questions? Please go ahead. Nihar, no. But we will be talking about monitoring when we learn during the course containers and cloud, right? When we learn the cloud and Kubernetes orchestration. At that time, we talk about monitoring, but we have now plans to discuss Prometheus. Not right now. Not to discuss. Okay. Anyone? Any questions? Please go ahead.
So, Basil, so we are going to start Linux with basics, right?
Yeah, that's what in the beginning. This week mostly we focus on that. Right. It's all about getting yourself comfortable with the Linux command line. It's important. We are not planning to learn Linux. Linux means it's a big topic list. For you, it's all about making yourself comfortable with the Linux command line and stuff. And throughout the training, we are going to use Linux. So that's what getting started is what it's all about. And nowadays, there is no reason for you to learn Linux actually in detail ever since the Docker and containerization came into picture. There is no need of administering a Linux operating system anymore. So it's all about getting you started.
Basil, excuse me.
Yes, Wilson.
Yeah, this is Delphine. We've been attending this class for 2 weeks now, and according to the plan of action you said we're going to start tomorrow, it seems as if you're going to start all over again from where we started. So I don't understand where we are at right now.
No, for you, the class starts at 7:30. Sorry, I think your class timing is, you are on the wrong class. We will start in about 10-15 minutes. Yeah, anyone
So,
else? Any questions?
so Basil, are you covering Ansible and Ansible as well in full term, or is it just going to be basic stuff?
Ansible we are covering, it's a 2 weeks training. It's a full stretch course. It come along with a project also. We are covering that in detail.
Okay, okay. And regarding this AWS, right? So are you more concerned about orchestration in cloud, or are you gonna tell more about services as well in AWS?
Services.
Like,
In
I mean,
as
services as well, or only containerization?
yeah, in the live training, we will be discussing only about the Kubernetes and containerization. What I said is there is an extra course which I will share with you. It's a self-paced training, including the videos. I will.
Gotcha.
This is all about service-based course. It's a 15 hours course.
Okay. Cool. Thank you, man.
Yeah. Anyone? Any questions? Cool. Yeah. I think we can wind up here today. We will start day after tomorrow. Same time, same link.